This is a video solution for practice exercise 1. For our week 3 practice exercise 1, we'll need to refer back to our week 2 challenge solve. Remembering that solve information is stored on the cloud and can only be shared if somebody is invited to that project. So you'll need to be viewing your own file as there isn't a supplied file to work with. But the main point of this is going to be learning how to filter different options inside of the Explore workspace. The first thing that I've done is I've minimized some of the options I'm not going to be looking at. For example, the study, processing status, or design file. We're going to be focusing on things like manufacturing method, material, as well as factor of safety. So first I want to notice in the objectives ranges that our slider bars will list the min and max of all of our designs. Notice that the max for our factor of safety is 2.05. This means that nearly all designs have hit the converge point of 2. So this means that filtering these out is a relatively simple process, and we can take a look at any that are above 2, and you can see in this case only one option remains. If we expand to the properties view, we can see that it's 5-axis milling and that its factor of safety is 2.05. We could click on it to explore this design further if we need to. So as we rotate it around, we can get a pretty good idea of the geometry and note a few areas where we could do some additional cleanup, for example, on the outside of these bosses. We can take a look at the mesh view as well as the export preview and get a good idea of what our actual part is going to look like. But let's take another look at some filtering options. I'm going to set the objective range slider for factor of safety back down to 2. And we're going to be taking a look at manufacturing methods. If I wanted to focus solely on 3-axis milling, then I could remove all the other manufacturing method options and focus on just those, in this case, the aluminum, that is the default material in our file, the aluminum that was added, as well as the steel material. We can instantly see the volume, relatively close. The mass is relatively close for our aluminum and the aluminum AISI, but the steel is obviously quite a bit heavier. Factor of safety is the same, the max displacement is actually relatively close, and the max von Mises stress is, in this case, not too far apart. You can see that they're relatively close as well. So these can help us narrow down and identify a design that could be a correct option for us. Let's go ahead and reset our manufacturing methods and take a look at the sort by option as well. So from here we can pick manufacturing method or material or factor of safety or any of the other options that might be important criteria for us. I like to sort first by manufacturing method as well as making sure the display has the properties view so that way I can quickly see information about each design, the manufacturing method, as well as the material and the orientation when we're talking about milling. When we get into 5-axis milling, we have our 3 materials. We can quickly take a look at the max displacement values as well as the mass. So you can see that the 2 aluminum versions are the same, while the steel version is over a pound heavier. Then we have our additive options, and as we're looking at these previews on the screen, the nice thing here is that we can actually take a look at the orientation. So we can see that X and Y plus and Z plus. Now the Z plus looks like it's potentially a better option. The geometry is more in line with what we would expect to see on this bracket, while the build orientation for X and Y orientations is not going to be ideal. And we also have some additional options all the way down in unrestricted. So this will show us for each aluminum material as well as the steel. Now we can actually see that the mass is lower on the unrestricted method because it doesn't have to worry so much about manufacturing method. It can go to idealized geometry. If we take a look at the steel version of this, we can get a really good idea of the geometry. As we zoom in, we can see that there are some small holes in this design, and if we navigate back to a mesh view, we can see that this is going to be a potential problem when trying to manufacture this part. So we can always roll back the iterations, go back to a version that was smooth, and just double check our values. So you can see that our mass in this case is 1.659, And if we go all the way to the end, it actually doesn't change that much. So this saves us a little bit of cleanup by simply going back a couple iterations to a smooth version before those holes were created. You can also see that there are some small holes in other areas, and these might be ones that we would need to clean up manually. Whether we're going to be taking a look at a mesh version of this, or if we're going to be exporting it as a 3D design. But this is a great way for us to navigate and filter out our options by using some of the on-screen options when we're talking about filtering through our outcomes. You can see here that we can filter by volume, by mass, by displacement, by stress, as well as use these sort by options up here to quickly organize everything to get a good idea exactly of what we want to find out about each design. For example, the factor of safety, the mass, the displacement, and then organizing them based on how they were manufactured. For this study, I'm going to be looking at unrestricted in aluminum, and I'm going to be exporting one of these designs to work with. But I suggest that you navigate through and take a look at each option. That way you can pick a design that works best for you.